Hello and welcome to file-based import-export overview. This is a GitLab feature that allows you to migrate your projects and groups from one instance of GitLab to another. It can be found under this URL for more information like using the API, what it does, etc. So I guess the first thing that we're going to do is show a quick demo of how it works. So I have a project page here. If you go to the general settings, under advanced, there's going to be an option to export the project, which is a sidekick background job, which creates a tarball and makes it available on under a certain URL. So you can generate a new export or download it. I already did that, so I'm not going to do it again. And then what it allows you to do is create a new project, and you upload this tarball. Testing 6. I've done it more than once already. So if you import this project, it should recreate the original state of the project that you exported. So as you can see, I have this project here with 5 issues, and I have this project here, also 5 issues, and they look alike. So, for instance, here's 8 issues here and 8 issues here. So that's a quick demo, and the same applies to groups. You can take the group, for example, I have a group right here. You can go to settings, general, and do exactly the same procedure, but you get an idea. I'm not gonna show it in full. So where it's used, like I mentioned, the first 2 topics, the project import-export and group import-export, and also import-export, file-based import-export is used in custom templates. The instance level, project level, and group level instance templates, which allow you to set up templates for your projects. Underneath this feature, import-export is used. Essentially, what's happening if you have a project and you set it as a template, then when you create a new project that is based off that template, underneath it exports that project, and then it imports it under a new destination. So you have like a template project to work with. So in a nutshell, on a very high level, what's happening is 2 things. We serialize on the export side. We serialize all the data to JSON, and we stream that content into the ND.json file. ND.json is essentially JSON, just a new line delimited. And what it allows us to do is to export and import projects with memory optimization in mind, so that our memory usage doesn't grow. Because before we had a project, a JSON file that was one massive object, and if you imagine that contains like an array of issues, an array of merge requests, an array of milestone, whatever, and let's say you have a project that has 10,000 labels, 10,000 issues, 10,000 merge requests. All of that is one massive object that we need to load in memory, which is not very memory efficient. So instead, so we serialize it to JSON, right? So, and you can imagine it being something like this: project.issues to JSON, as simple as that. And we pass a list of options, which subrelations to include. And this is an example. This is not an accurate representation of what's included. The actual list of included relations is pretty big, and I'll show you where to find it later. That's like on the high level on the export side. Here's the export issues that ND-JSON file, and as you can see, every line is a valid JSON object, and every line represents an issue. On the import side, we again on the high level, and I'm gonna go a bit more into detail later. On the import side, we read those files, we consume them line by line, and then we do some processing on the line that we read. For instance, we convert the JSON object into the active record object, including the subrelations recursively. So if you can imagine, you have an issue, and I included the screenshot here to kind of better illustrate what I'm trying to say. So we have the relation object, which is an issue. As you can see, it doesn't have an ID yet, and it's not persisted in the database. I put a breaking point in the code just to illustrate it better. So from the example above, right, you have an issue, and that issue includes nodes. You know, it's kind of hard to read, but I cannot find where it says nodes, but one issue can have nodes. One node can have award emojis associated with it. You know, so every object, when it's serialized, it can be quite big, and it has nested relations in it. So on import, what's happening is that we convert that string recursively, and we identify what's included, what kind of relation it is, and we convert them into objects. So if let's say you have an issue with 10 nodes in it, we convert an issue into an issue object, and every node is converted into a node object as well. So like I said, right here we have an issue that is not persisted yet, and that issue has associated nodes with it, which is a collection of nodes. And as you can see, this node doesn't have an ID. Neither of these nodes have are persisted. And as you can see here, every node has an author, and this author is root, the importer user in this case. I'll touch on the user mapping a little bit later as well. And once we convert all of the subrelations into objects, it gets persisted, and you know, we move on to the next object. So the import-export contents on the left here, this is the content of the tarball. All of the information that we need in order to perform an import. There are LFS object references, there are snippet repositories, there will be uploads if there are any uploads in there, and there's also all of these ND-JSON files that I just mentioned. You know, like issues, labels, merge requests, milestones, etc. And on the right, this is the export service. There is a list of exporters or savers that this service calls that exports all the required things that we need. Like I said here, you know, the project tree, the avatar exporter, the repo, the uploads, etc. So all of these exporters can write on disk, then all of that gets packaged into the tarball, compressed, and then, you know, uploaded for you to download. So where do these things come from? How do we know what to export and what to import? Well, there's a main file for both import, for project import export, and for group import export is the import export YAML file. And this file defines what we are going to include, what kind of relations we are interested in, what we are going to exclude, what kind of attributes we want to see in the exported file. So for example, yeah, in order to show a little bit more detail, we have an import-export project import-export YAML file. As you can see, it's quite big. For groups, it's a little bit smaller, but for projects, it's quite big. We also have a section for EE. If you have, let's say, epic references, which is an EE only feature, you put them under the EE category. So that's where you define your relations. And as you can see here, all of the top level relations right here under tree project are the ones that are going to generate the NDJSON file. So for example, labels, milestones, issues are going to generate issues NDJSON, labels NDJSON, milestones NDJSON, and you can see, like, you can pick any file from here. It will map to a top level relation here. One thing on debugging, like there are two ways to kind of observe and if something goes wrong. Let's say something is missing, right? You import a project and one issue is missing. There are two things that can help you identify what was wrong. One thing is the importer.log file under the development repository, under the local developer environments. This file is located under log/importer.log. We have on production in Kibana, I think it's a tag that you need to put, like importer true or something. I don't remember exactly, but it is possible to view importer only records on the I think it should be in the sidekick index. I remember there was a catch that some of the logs are not where you expect them to be. But anyway, on the developer environment, it should be under importer.log. And there's also import failures database table that tracks all of the failures that happened. Let's say that issue that failed to be created, it should have a record in this table as well regarding what failed. So for example, if I show tree relation tree restore, just to show you where it's happening, like here's the method called process relation item. Here's where we call save on the relation object that I showed you previously, that issue that doesn't have an ID. So we just rescue an exception and we create an import failure record in the database for that. Yeah. Okay, next, some of the key components when it comes to import-export. So the export side is quite simple. We have an export service that has a number of exporters that I actually showed previously, right? Every exporter is called, that has its own responsibility, and it writes the file. Once all of them succeeded, we package that up. That happens in the saver. We compress and save, and we upload that using carrier wave gem. It's all handled for us. And then we remove the temp directory. One thing to note is that before we upload it to object storage, we need to write somewhere. All of these exporters, they need to write their data somewhere, and we write that on the temp directory on disk. But it's not a temp directory that is temp tier. It's a temp directory that is actually under shared under shared path. I'm gonna show you now. So I think TMP, no, shared TMP. That's the directory, and some of you may know that this directory here represents NFS mount, especially on .com. It can indicate that this is an NFS mount, but import-export does not have NFS dependency. It just happens to be writing under this path. I'm not too sure why, but this is more of a legacy historical reason. The import-export itself is single process. It does not require files written to be on NFS. It doesn't share any files with any other processes. So just a note on that for anyone who notices this. So yeah, we compress that, we upload the tarball. Then these two things here, the streaming serializer and the anti-JSON writer, are applicable specifically to the project tree saver. So what the streaming serializer does is it serializes the relations in batches and uses the JSON writer to write them to the destination. This thing that I showed you here, the two JSON calls, this is what's basically it's doing. It parses the whole YAML file. It constructs the list of options for this to JSON call, and then in batches it performs these operations. It retrieves, a batch of, let's say in this case issues. It retrieves a batch of issues, and then using the ND-JSON writer, it writes to them to, well, I guess the ND-JSON writer writes them to file, but the streaming serializer uses the ND-JSON writer to do that, to accomplish that. Yeah, as you can see here, exportable.public send key is essentially project.issues, and then depending on type of the relation, if it's a many relation, if it's an array of data, or if it's a single relation, and we have a few of those, like there's got to be distinction between a collection of data like project labels versus service desk setting or CI/CD settings, something that is auto DevOps, something that is not a collection, something that's just a single object of data. There's a distinction between those, and that's all handled here. And then depending on type of data, here for example we have a serialized menu relations. We do that in batches. We preload stuff that needs to be preload, and when it comes to individual records, right here is where it's happening. Record that to JSON, and we pass in the options. And then we take that, and JSON writer does the writing, and then the end result is the ND-JSON file. For import, it gets a little bit more difficult because there are a lot of things that need to happen. When they export, just serialize everything to JSON, and that's it. For import, there are a few more things that need to happen. So I guess the very first thing that's happening is this importer. This is similar to the saver. We have to the export service with a list of exporters. The importer has a list of restorers, as we call them. So you import the file and you call each of those importers. The very first step is import repository, then wiki, then project tree. I guess the project tree is going to be my main focus here. So here's the tree restorer. This is the one that is getting called, and the tree restorer is the entry point essentially, right? I mean, not entirely true, because there's a code path leading to this point, but that's where the tree restorer kicks in and restores data from the ng-json files. So here we consume relations using the relation reader, and the relation reader is the ng-json reader, right? So we open the file for reading, and we consume relations from that one by one. And then we pass that to the relation tree restorer. I guess this is where everything starts to be even more difficult than before. Because as you can see, even the method signature is huge. We have members mapper, object builder, relation factory, reader. What are those things, right? So I'll try to mention what they are, but obviously I won't be able to cover all of them in detail. So the main thing is the relation tree restorer, and what it does is, this is where all of the relations are not consumed, but I guess processed and traversed. So for every relation hash, this is where the actual replacement of strings into objects happens. Well, this is where we call the class that is doing that. So the actual replacement is happening in the relation factory, but this is like the class that holds all of these objects and either passes them down the line or uses them for something else. So in this case, the relation tree restorer, it's actually the place where that save happens on the transformed object, like something that I showed you previously. Like the relation object that save is when we persist it in the database, but all of the conversions are happening in this class too, in a sense that we traverse data, and depending on the type of data that we identify, whether it's if there is an array inside of our object, then we need to recursively process every item in that array, and if that item has another array in it, we have to go and process those too. So this is where we do the traversal of building relations and transforming subrelations. I won't go into detail for this bit, but for every relation, we essentially call the relation factory.create. And before I move to that, just one thing to note. I guess I mentioned that before, that if the save failed, we create an import failure record in the database, which can be helpful identifying what can be wrong, right? So regarding the relation factory, I guess this is where a string like this gets replaced into a label like that. And yeah, it has a lot of stuff in here, trying to accommodate because it's a relation factory, it tries to accommodate for every possible scenario. Like, for instance, we have a huge list of overrides, which are essentially a list of things. It's like a map. For example, if you have project.ci pipelines, we replace CI pipelines with this class. We map what is the CI pipeline, and some of the relations don't require this, but some do. And that's the reason for it, because Active Record doesn't know what is commit author, right? So we help it identify, oh, commit author is actually this model. And there are a number of other things that we help the relation factory with. For example, the existing object relations. I'm gonna touch on this actually right after with the object builder. But existing objects relations is essentially this. If you have a list of issues, right, you just work through every issue and you just create them, right? Simple. But with a certain relations, that's not necessarily the case. For example, labels or milestones. If you have an issue, if you have two issues, in fact, that reference the same label, you don't want for every issue that you create, you don't want to create a duplicate label or a duplicate milestone, right? So you want to create this label for the first occurrence of the issue, if the label does not exist yet, but for the second one, you know that it's already there, and object builder is the place that is responsible for making sure that you reference existing label instead of creating a new one. That's it. But yeah, the relation factory is where all of the modifications happen to the hash that you have. For example, depending on the relation type, we perform certain things. If it's a node, we set up the node appropriately. If it's a pipeline, we do something else. And we don't have a lot of models, as you can see here, that require such modifications. Most of the time, the exported hash is enough. We don't need to do anything about it. But there are certain situations where we do need to set it up. For example, for divs, we apparently delete UTF-8 div for whatever reason. Yeah, so this is where we transform. We take the relation name, we convert it. We convert the string to the file. To the object. I guess it's happening actually here. This is the subclass of the base relation factory. Yeah, there's a lot of the things going on, but we replace user references, and that's responsible for the responsibility of members mapper, and I'll touch on that in a second. We remove duplicate assignees, we reset the tokens, any occurrences of encrypted attributes, we remove those as well. I just want to quickly show you where the actual creation of the object happens, right? From the hash to the actual object. But it's essentially right here in the existing or new object. Relation class.new, as simple as that. There are a few more things that happened before that, like cleaning the attributes, security related things that we don't because it's a tarball, we don't necessarily want to. It's user editable, right? A user can maliciously or otherwise, edit the tarball, make it look like it's legit, and then upload it and look for some sort of unexpected behavior. So there is a process for that as well. And if you're curious, it's attribute cleaner is the one responsible for making sure that the passed in hash is clean. All the references of IDs are removed. For example, here is a list of prohibited references. Everything that ends on _ID or IDs or HTML gets removed, except for a few things that are allowed, but I won't go through them. Yeah, this is where the transformation happens. There are a few cases where if it's a unique relation, we want to do something else. If it's an existing object, we want to do something else. So there are a few things that we do here to accommodate for different types of relations, right? Yeah. So object builder, like I told you, if it's an existing object, we want to do something else. We don't want to create a new one. So what's happening is we are trying to create a new object using the object builder. And here in the find or create object, we do some manipulation with the group, with the IDs, but here's the object builder.build. And the object builder, like I said, it's used to find an existing relation, Do not create a milestone duplicate, or to not create a label duplicate. So we have an object builder, and it's it's somewhat simple, because what we do is we take a list of attributes and we take the class, and on a high level it's this, right? We either find an object using the list of attributes that we passed, or we create a new one. And for project object builder, these attributes are either project ID or a group ID, and then the title. I'm pretty sure there's more. I think there's title, things like title here, title, description, and created at, and project ID or a group ID. So, and this has been proven enough to be able to identify existing objects instead of creating duplicates. So if there are two issues, issue 1 creates the label, issue 2, oh, there's a label with title A, description B, and created at this, we check, does this label exist? And already, yes, use that instead. Don't create a new one. And something that I mentioned before in the user references. In the relation factory, we update user references. So for every user reference that is described here, things like author ID, user ID, etc. Obviously, we cannot preserve these. We need to replace them with something else. A user with ID 1 on my instance is root. On GitLab.com, it's someone else. I cannot just upload a project and suddenly Sid authored everything I have, right? So on any occurrence of these references, we replace them with the references that we built using the members mapper. A members mapper runs at the very beginning because we don't rerun the mapper every time we see a new occurrence of the user reference. We build it once and we pass it along to the relation factory. And here is Yeah, every exported relation has some sort of a user reference, and we use the public email that was exported from user, or the email for older exports. This has been a recent change to use public email only and not use the email, but in order to provide backwards compatibility with older exports, we use email as well. We try to identify the user, and then it's essentially a map, right? For old user ID 1 with the email whatever, this public email whatever, on the new instance it's actually, you know, a user under ID 5, and we use this public email information. We use verified, you know, primary email, so it's not a secondary or unverified or whatever. It should match the source instance primary email address. And one thing to note, this whole members mapping functionality works if you're an admin. If you import or user initiates an import and you're an admin, then a user mapping will work. You know, let's say I left a comment on an issue and then I import this project somewhere else, and if my user exists, I will show up as an author of that note as well. But if I'm not an admin, when I'm initiating the import, then all of the user references are going to belong to the import user. So every node will say created by, you know, by somebody else, some other user at this time, and here's the content. But the author of this node will be the person who requested who imported this project, right? Yeah, so here we build a map, and we also add found members to the project as project members. Yeah, and yeah, that's what it is. So yeah, there's a lot going on in import export, especially in import, because, you know, export is quite simple procedure, but import, you have a lot of things that you need to cover, and a relation factory is quite extensive. There's a lot to read and to understand, and it can be quite overwhelming to grasp everything, right? And but yeah, that's, I hope this was helpful, a helpful overview of what import export does and what are these classes and what they are responsible for. Other things to mention, yeah, like I said before, all of the above exists for group import export, separate file, separate importer classes, mostly subclasses, because they all share a lot of functionality. There's an import export API that you can use to initiate. It's not only in the UI, it's also via the API. And another kind of last note is that for exports, it's possible, especially when done via the API, you can pass and import your upload URL and upload params in order to upload the tarball to the provided URL. For example, if you have a long-running export and you want to upload it directly to a storage, something like an AWS S3 bucket, you know, you can provide that URL and the file will be uploaded there. In a way, it's like a webhook, yeah. But yeah, I hope I didn't miss anything, but this has been a high-level overview of import and export. That's it. Thank you.